So if you look at the first section, it's going to ask you to write your answer for all solutions and for 0 to 2 pi. So you're going to have two sets of answers for the first couple problems. And if you notice here, all of these thetas are by themselves, which means that these are kind of like old problems and that the period of the graph has not changed. So from 0 to 2 pi, we're still going to expect two answers like normal. Okay, so let's go ahead and start here. I still have to think about doing tan inverse, which means I go and I look at my unit circle and I see where the y-coordinate divided by the x-coordinate equals 1. So where on the unit circle does the y-coordinate divided by the x-coordinate equal 1? 5 fourths and 5 pi fourths. Now for tangent, do we have to use both of those? No, we only have to use one because tangent repeats every pi. Okay, so instead of saying pi equals pi fourths, I'm going to say that all of this stuff, pi plus 5 pi 6 equals pi fourths, and then I'm going to write plus pi k. Okay, so the reason I'm writing this is because this is the inside of the parentheses, so this is what I got when I did tan inverse. When I did tan inverse, I got rid of the tan, and then the parentheses were all alone right here. When I did tan inverse of 1, I looked at my unit circle, and I could see that tan inverse of 1 is pi fourths. And then I wrote plus pi k so I can get all the other answers. Okay, so if I want to get theta alone, what should I do with this 5, 6? I should subtract it. So in my calculator, and this is why we have calculators out today, it's not because we have decimal answers, it's because there's a lot of fractions today and the calculator will save you some time, okay? So I'm going to do 1/4 for the pi fourths, and I'm going to minus 5 pi 6 from that. So minus 5 6. And then I'm going to hit the math button, turn it into a fraction. So when I subtract 5 pi 6 from each side, I end up getting that theta is negative 7 pi 12ths plus pi k. And this is the answer that represents all solutions. So I'm not worried about it being negative because I have not yet answered the question, what are the answers from 0 to 2 pi? Okay, so this is just the answer for all solutions. Negatives are fine. Okay, now I'm going to go ahead and find the answer for 0 to 2 pi. And since the period of the graph, or since the answers are still for just theta, that means I'm going to expect to see two answers for this problem. Okay, so I can't write down the negative version because it's not between 0 and 2 pi. So I'm going to type negative 7 12ths. And I'm going to add 1 to it, and that's like me adding 1 pi. So 5 pi 12ths is my first answer. And then I'm going to add 1 again. And 17 pi 12ths is my second answer. And if I was to add 1 again, 29 12ths is bigger than 24 12ths. And so that means it's bigger than 2. So we're not going to write that one down because that would be too big. Yes. So when I type something in, like if I type 29 12ths and I get that decimal, if you hit the math button, the first option lets you convert it into a fraction. And so I just press enter, enter, and then it puts it in a fraction. If you want to type it as a fraction, you can hit alpha y equals and use the first option. And then if you type everything in as fractions, it will give you fractions as answers. So there's two different ways to kind of type it, and it just comes down to your preference for how you can make the fractions show up in your calculator. Okay. For the other three problems, which one would you guys like to do as a class? 2, 3, or 4? 4? Okay. So for this one, we have to do sine inverse. And since we're doing sine inverse, that means we're going to look at our unit circle. And we're going to find on our unit circle where the y-coordinate is positive root 3 over 2. Pi thirds and 2 pi thirds. So I'm going to say theta plus 5 pi over 6 equals pi thirds plus 2 pi k. And theta plus 5 pi 6 equals 2 pi thirds plus 2 pi k. So when we start to do these more complicated problems, we always default to writing all solutions first. So if you guys can see that, I'm keeping the 2 pi k tacked on the end, okay? Okay, so for each of these equations, what should I do next? Subtract the 5 pi 6. And the reason I'm subtracting it only from the pi thirds and not from the 2 pi k is because I'm only allowed to subtract or add like terms. This one has a k on it, so it is not considered to be like terms. So that's why you can only subtract it from the other one. So I'm going to go ahead and do 1/3 minus 5/6. So you can see if I type it like this, then it gives my answer in the fraction form. If I don't type it like that, then I have to convert my answer to a fraction. So this would be theta equals negative pi halves plus 2 pi k. And then for this one, we'll also subtract the 5/6. And I get negative 1/6. And so these are my two solutions for the part of the instructions that say to find all solutions. And again, negatives are okay here because it says all solutions. And then if I just want the positive solutions from 0 to 2 pi, this graph still has a period of 2 pi, so I'm expecting that only 2 answers will show up, okay? So negative pi halves, if I add 2 pi to that and find the coterminal angle, anyone know that off the top of their head? 3 pi halves, And that's it, right? Because if I add 2 pi again, it's going to be way too big. And then for this one, negative pi 6, I would not write down because that's negative, but if I think about adding 2 pi to it to find the coterminal angle, 11 pi 6. And again, I'm not going to keep adding 2 pi because it's going to be way too big. So when I think about which answers are from 0 to 2 pi, I only have 2 answers, which is what I expected because the period was normal. So 2 answers on a unit circle is pretty normal for us. Yeah. So the reason I only added 1 to number 1 is because it was a tangent problem. And tangent problems, you just write one equation and you have plus pi k. And then this was the sine problem. All right, so I'm going to give you guys a couple minutes to work on 2 or 3. And then after that, we'll go ahead and we'll try one of the next level of like difficulty. How are the problems going so far? 2 and 3? Are they okay? Yes, no. You're very focused, so you're quiet. How many more minutes do you want before we go over one that has a number in front of the theta? 3 more minutes? Okay. wanted to work on your quest.
Yes, ma'am.
Do you have anything with you today? Then it's all directed.
Hi. I'm finishing out as well. This is from the.
Yes.
I have been sent out. I was like, I think that looks familiar.
Yeah.
This was from yesterday.
Yes.
I think I put it.
And I'm gonna have one of you stay in here. I don't care who, but one of you can sit at that back table. Hey, Kamaya, I don't want both of you outside taking the same thing, so you're going to sit in the back. All right, we're going to go ahead and do a problem in the next section. So, if we look right here, we'll go ahead and we can do a tangent one and then one of the other ones again. So would you guys rather do, actually let's go ahead and do 5. We're going to do 5. So with this one, if there were parentheses, they would have been right here. That's why they didn't put them, because they weren't really necessary. So what we're going to do first is we're going to think about doing sine inverse, which means we're looking at the unit circle and we're looking for where there's a y coordinate of positive root 3 over 2. And where does that happen? Pi thirds and 2 pi thirds. So this time I'm still going to take the inside of the parentheses, but I'm going to say 2 theta equals pi thirds plus 2 pi k, and 2 theta equals 2 pi thirds plus 2 pi k. And we know that the 2 in front of the theta is going to change the period of the graph. How is it going to change it? Instead of being 2 pi, the period would be pi, because we would do 2 pi divided by 2. So that means we're going to get 2 answers from 0 to pi and 2 answers from pi to 2 pi, which means for this problem we're going to expect to have 4 answers. Okay? So I'm going to go through and I'm going to say divide by 2, divide by 2, divide by 2. So I'm dividing the entire equation. And I get theta equals, what happens if I do 1/3 and I divide it by 2? 1/6. So we're going to have pi over 6. And then 2 pi divided by 2 is pi. And that's what we expected, right? We said the new period of this graph would be pi. So that fits what we expected. Over here, I'm going to divide by 2, divide by 2, divide by 2. I get theta equals 2/3 divided by 2 would be 2/6, which is pi thirds, plus pi k. So those are our answers if we want all solutions. The instructions are asking us just to give the answers from 0 to 2 pi, and the reason I have this as the instructions is because I know you have to do this answer anyway, so I'm kind of making you do both, if that makes sense. So first I'm going to write pi over 6. That's my first answer. Now for this one, since we're just adding 1, we could probably do this without a calculator because we're adding 6/6, right? So if I have 1/6 and I'm adding 6/6, then my next one is 7. If I add 6/6 again, I'm going to have 13/6, which is too big. That's bigger than 2, because 12/6 would be 2, right? So 13 is too big, so we're done with the answers from this one. With this one, we're going to start off with the pi thirds. And then I'm going to add 3/3 to that, and what do I get? 4 pi thirds. And if I added 3/3 again, I would get 7 pi thirds, which is too big, okay? And so we got 4 answers, which is exactly what we expected. So if the period of the graph is pi, then that means we're going to have 2 answers from 0 to pi, and then 2 answers from pi to 2 pi. So you can see the 2 answers from 0 to pi were these two, pi 6 and pi thirds, and then the 2 answers from pi to 2 pi were the 7 pi 6 and the 4 pi thirds. So normally if you don't change the theta, if it's just theta like in questions 1 through 4, normally we find 2 spots on the unit circle for our answer. So if we change the period of the graph, that's when we start to find sets of 2. Answers in sets of 2, and this gives us 2 sets of 2. Okay, so let's go down to number 7. For this one, I'm going to look at the unit circle. I'm doing tan inverse, right? And I'm looking at the unit circle to see where a y-coordinate divided by an x-coordinate equals 1. And where does that happen? Pi fourths and 5 pi fourths. Do I have to write both of those down? No, because this is tangent, so I only write down 1. So I'm going to say pi thirds equals pi fourths plus pi k. Or you could have said pi thirds equals pi fourths, or sorry, 5 pi fourths plus pi k. You could have done it either way. And we're going to multiply by 3 to get rid of the fraction. So multiply by 3, multiply by 3. So what happens if I do 3 multiplied by 3 pi fourths? I get 3 pi fourths. And what happens if I do 3 times 3 pi k? Yeah, 3 pi k. I said the answer instead of the question. Okay. So what this means is for every set of 3 pi, we would have 2 answers, which means that from 0 to 2 pi, we're probably only going to have 1 answer. Does that make sense? The period of this graph would be 3 pi k, so we're probably only going to have 1 answer between 0 and 2 pi, but we could possibly have 2 depending on where the answers fall, okay? So I'm going to say theta equals 3 pi fourths, because that answer was positive. If I take 3/4 and I add a whole period of the graph, if I add 3 to that, that's going to be way bigger than 2 pi. And so that means I only have this 1 answer to write down. Okay. Go ahead and try number 6 and 8. Okay, I think I'm gonna start you guys off on, let's do number 12, because this one is kind of obnoxious. When it has that 4 in front of the theta, how many answers, let me unfreeze this. How many answers do you think we're gonna find because of that 4? We're gonna find 8 answers. So if you think about the period of the graph, it doesn't. We'll do 13 after this, so you can see why it doesn't have 14 answers. So number 12, if we think about the period of a normal graph, the period of a normal graph is 2 pi, right? And we usually have 2 answers for 2 pi. So if I do 2 pi divided by 4, what's the period of my new graph? Pi halves. So that means we have 2 answers for 0 to pi halves, 2 answers from pi halves to pi, 2 answers from pi to 3 pi halves, and 2 answers from 3 pi halves to 2 pi. So that's 8 answers total. Does that make sense how I'm thinking through that? Okay, so let's go ahead and think about our unit circle. Where on the unit circle do we have a y-coordinate of -1/2? Because I'm doing sine inverse. 7 pi 6 and 11 pi 6. Okay, so I've got 4 theta minus pi fourths equals 7 pi 6 plus 2 pi k. There's my first equation. And my second equation is 4 theta minus pi fourths equals 11 pi sixths plus 2 pi k. So on the front page, we only had one step to do. On this page, we're going to have 2 steps because we have a number in front of theta and we have a number that's being added or subtracted. Okay, 2 different steps are happening. So which step do I do first? I add. I add the pi fourths over first. So add pi fourths. Okay, so 7/6 plus pi fourths is, okay, so we have 17 pi twelfths plus 2 pi k. And then if we have 11/6 and we add pi fourths, is 25 pi twelfths. Now, not all the problems are going to be as annoying as this one. I chose a particularly bad one to go over with you. Okay, so you'll notice that most of them don't go for this many answers. Okay. All right, now what do I do to get the theta all alone? Divide by 4. So divide by 4, divide by 4, divide by 4. Theta equals 17 over 48. So 17 pi over 48 plus, Mallory, are you listening? And what does this become? Pi halves. Okay, and then over here, divide by 4, divide by 4, divide by 4, and we get theta equals 25 over 48. Okay. So since the period of the graph is pi halves, we're going to expect to get 4 answers from this one and 4 answers from this one. Okay, we get half from each. So theta equals, I'm going to go ahead and type 17/48 in my calculator. And I'm adding 1/2. So there's my first 4 answers, and I added 1/2, added 1/2, added 1/2. If you notice, if I were to add 1/2 again, I get 2.3, which is what tells me that it's too big. Or if I look at the fraction, I have 113 over 48, which is bigger than 96 over 48. And 96 over 48 would be as big as I could go. All right. So there's my first 4 answers. Now I have to switch equations, and I'm looking for the second set of 4 answers. So I've got 25 over 48. I'm going to add 1/2. (49 over 48). And when I go to add 1/2 for the 4th time, I get an answer that's bigger than 2. You guys see that? Or if I look at the fraction, I get 97 over 48 when I'm only supposed to have something smaller than 96 over 48. But I only have 3 answers. I was supposed to get 4. So anyone remember from the video how we find the 4th answer? We subtract instead of add. So I go back to the very first one, the 25 over 48. And instead of adding 1/2, I subtract 1/2. Subtracting is always an option, it's just not as common. So sometimes we'll need to subtract, and I can see when I subtracted, I did get something that was positive. So if I look at this, 1/48 was the last answer. And there's our 8 solutions. So these problems, there can be lots of them and they look pretty terrible, but the math to find them isn't too bad, and the math to find them is very repetitive. Okay. All right, let's jump down to number 13. How many answers, when you look at this problem right away, how many answers are you expecting? 14. It feels like there should be 14 answers. This is one of the exceptions to the rule, and the reason is because if we think about doing cos inverse, and we look at the unit circle, an x-coordinate of 1 does not happen twice. How many times, or where does an x-coordinate of 1 happen? On your unit circle, where does an x-coordinate of 1 happen? At 0 pi or 2 pi, it doesn't matter which one we think of it as. So for this one, because that answer only happens normally once on the unit circle, that means we're only going to find 7 answers, not 14. So answers like 1/2 or root 3 over 2 or root 2 over 2, those all happen twice on the unit circle. But one like this that only happens once means we don't actually have to double the number of answers. So here we're truly just going to get 7 answers, which is kind of nice, okay, because 14 would have been a lot. So cos inverse of 1, it can equal 0 or it can equal 2 pi. Which one would you guys rather use? 2 pi? Okay, so I'm going to say 7 theta plus pi thirds equals 2 pi plus 2 pi k. And I only have one equation because this answer only happens once. And I'm using 2 pi, but I could have used 0 pi. It does not matter. Okay? All right, so what should I do first? Subtract pi thirds. And if you do 2 pi and you subtract pi thirds, what do you get? Two pi minus 1/3, or 6/3 minus 1/3. 5 pi thirds plus 2 pi k. All right, and then what do we do? Divide by 7. So theta equals 5 pi 21 plus 2 pi 7ths k. And we are expecting 7 answers. So we've got 5 pi over 21, and then I'm going to go ahead and add 2 sevenths. Yeah, so here's the trick that I usually use. Hold on, let me write this. I can't multitask. 17 pi. Okay, so here's the trick that I use to make it so I don't have to keep typing this. I'll go ahead and do alpha y equals, and I'm going to do 5 over 21. And then what I do is I press enter so I get it so it's just on the screen like that. And then I hit plus, and then I do alpha and then 2 sevenths. And what you can do now is you can just press enter, 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 and it will keep adding 2 sevenths repeatedly. Oh, but not 2, yeah, 2 sevenths. So 5 over 21, 11 over 21, 17 over 21, 23 over 21. All right, so the last answer I got was 41 over 21. Should I keep going? No. And that's, first of all, because I have 7 answers already, but second of all, because 2 pi would have been 42 over 21. So I know if I add 2 sevenths again, it's going to be 2 pi. Okay, so 7 answers, there they are. If I had only gotten 6 answers, what would I need to do? I would have gone back to the 5 over 21 and I would have subtracted 2 sevenths.